Welcome to another video of Embedded Blockchain. If you are new to this channel, I hope you enjoy our videos and don't forget to hit the like button and the subscribe button. If you are not new to this channel, then welcome back and don't forget to hit the like button. In this video, I will explain how to access and modify registers in a microcontroller. I will start by explaining pointers, which is essential to understanding how to access registers. In C, we have something called pointers. A pointer is a variable type that can store the address of other variables. By using a pointer, we can manipulate the address of memory. The syntax of a pointer is, first, we specify the data type, and then the name of the pointer preceded by an asterisk. Let's analyze the following example. We have declared a variable x, which is stored at address 0f. Then we declare a pointer of type integer using the asterisk. Then we assign the address of the variable x to the pointer. When we do this, the pointer variable takes the value of the address in which variable x is stored. We now have a pointer which contains a reference to the variable x. In order to modify the address of the variable x, we have to dereference the pointer. This is done by typing the asterisk in front of the pointer. When we do this, we are telling the compiler to modify the address contained in the pointer. Then we assign the value, and this value is written in the address where the variable x is stored. But how do I access a specific memory address? Let's say I want to modify address 1A. We can do this in C by writing the address and casting it to a pointer type. This is not a variable and cannot be modified. To make it modifiable, we need to dereference it. We do this by adding an asterisk in front of it. We can now assign a value to it. The value is written to the address we are specifying. This is how we can access registers and modify them in our microcontroller. Let's look at a practical example. If you go to the MSP 430 datasheet, section 11, digital input-output registers, you will find the address for each register for port 1, for example. In order to modify the output port of the microcontroller, we need to write the value P1out register, which has an address 21. This register is 8 bits long. Each bit corresponds to one pin in the port. If you have an LED connected to the pin, for example, your LED will turn on or off. Okay, let's look at the practical example of how to modify the register in the MSP 430. We have our main file, our main function. First, let's include the library, the standard library. Then, let's suppose we want to modify port 1 out. The address for port 1 is 21. First step is to cast this to a pointer type. This is not yet a modifiable value. If I compile this, it compiles successfully. Let's try to assign a value. And we compile. We get the error, expression must be a modifiable value. That is, this is not modifiable. To make it modifiable, we need to put an asterisk in front of it. Now we compile, and it builds successfully. And now assign a value to this specific address in memory. Now, if you look at the datasheet of the MSP430, you will see that for each port, all the addresses are in a continuous manner. It starts, for example, port 1, it starts at address 020, and then 21, 22, until 27. All registers for port 1 are in a continuous manner. We can take advantage of this to define a structure to access all of the registers. We can define a structured data type like this. So each element of the structure indicates each register in the port. We name them after the registers: in, out, direction, input flag, etc. We know that port 1 begins at address 020. We will name this port 1 base address. We can define a port like this. We define the name of the port. We cast it as a structure type pointer, and we give it the base address of the port. We now have access to each one of the registers of the port. We can now replace this with port 1. We can access each register by typing dot and the register we want to access, in this case out, and we assign the value. This is how we can define our structure to access each register in the port. We can do the same for all ports, just by defining a different base address.